started a new one. All right, so again, denominators are already the same, so I know my answer is going to be in quarters, right? And then just 1 plus 3. So I'm essentially just going right across the board for the numerators, right? So I end up with 4 over 4. What would be the lowest term for 4 over 4? Yep, your microphones are on mute, but I did see a few mouths. And yeah, 4 over 4 is 1 whole, right? 1 whole. How about if I had this one? Oh, question number 2, we'll say okay. So again, remember, apples and apples. These guys are the same. So my answer is going to be something in the 8ths. And then I just come right across the board up here. 3 plus the 1, 4/8. But I always want to express in lowest terms. Okay? Because especially if you're hollering out numbers on a tape measure, it's unlikely that someone would say, cut me that at 4/8. Right? It'll be most likely going to be what? What is 4/8 in its lowest? What's that, Ahmed?
A quarter.
A quarter? All right, let's see.
1 over 2.
What? It's going to be the 1 over 2. And here's why. Because 4 will go into itself once. But 4 will go into 8 2 times. Right? So if you remember back at this one here, right? So if we were to say, there's 1/2, right? There's the 4/8. Again, do you see the correlation? Right? 4/8, here, let me pull that back up. Right? 4/8 is essentially the same as 1/2. I could have brought 4/8 down to the 2/4, right? And then kind of realized, oh yeah, it can go down lower. Rule of thumb here, guys, is if I've got 2 even numbers, an even number as my numerator and an even number as my denominator, rule of thumb is it's usually going to be able to go down a little lower. Once you start getting into an odd number over an even, we're essentially most likely going to be at our lowest term, right? I can't go any lower than 1 over 2, okay? Because I'm just going to get 1 over 2 again. All right. So how about, let's try this one on. So third question, I'm going to go with 1 over 2 plus 1 over 4. Take a look at the denominators. I have an apple and an orange. Think about what you're going to do.
So it's going to be 3 over 4?
3 over 4. No. Right? So again, remember, I got to put these into the same, right? They have to be common denominators. Well, 4 will go into itself and 2 will also go into the 4, right? These two are multiples of each other. So I'm going to turn this 2 into the 4. So I have to multiply that by 2, which means I have to do the same thing up there. So now essentially this becomes 2 over 4 plus 1 over 4, because that can stay the same. Right? Now I've got apples to apples. And I go across. So yes, you were correct. 3 over 4, 3/4. But my 3/4 can't go any lower than that. Would you guys agree? Right? Because 3 won't go into 4 evenly. Right? There's nothing that will go into both of these numbers evenly. So it is in its lowest term. Okay? It can't go any lower than that. Let's try this one out. Ooh. How about this one? I'm going to go 5/6 plus 1/4. Now we can't go, I'm not going to say anything yet. I'm going to see what you do with this one. I've got an apple and an orange. We've got to find a multiple that both of these numbers can go into evenly. What do you guys think? Let's look at the biggest number first. So the 6. Is there a number that 6 will go evenly into, that 4 will also go evenly into?
12.
Yes, absolutely. It's 12, right? So we're going to say 12. So it's going to be something over 12 plus something over 12. So what I'm going to do is, to get to 12, I need to multiply 6 by 2. So I got to do the same thing to that 5, right? So 5 times 2 is going to be the 10. When I look over at the 4, in order to get 4 to 12, I have to multiply it by 3, right? 4, 8, 12. I have to do the same thing up here. So essentially, 3 over 12. Now I have apples and apples. So the answer is going to be something over 12. And in this case, 13. Is that my lowest term? Take a look at this. Take a look at the numerator and the denominator. Right? Is this my lowest term? Yeah, I see Philman shaking his head. Right? Hang on one second.
Is that going to be 1 over 12?
You got it. Absolutely. Hang on. I'm just going to let Aaron in. I think Aaron's here. Yeah, there we go. There you go.
Can I ask a question, please?
Yeah, absolutely. Hey, Aaron, just so you know, I've been recording any of the stuff that you've missed, okay? So go ahead, Philman. What were you going to ask, hon?
About this 5 over 6, the denominators times by 2. How can we make it times 2?
Because yep.
A little complicated, yeah.
Okay. So because I had this originally, and I'll write that original equation out again. I'm still recording? Yep. So this was the original equation I had, right? Again, I have two different numbers, or an apple and an orange, right? Well, I can't use 6 as my common denominator because 4 won't go into 6 evenly, right? It's going to have a fraction or a decimal. So I need to find something, remember, a multiple, right? A multiple, and if I go back to, I think this one here, right? So we need something that is a multiple of all the bottom numbers. Something that all bottom numbers, it's kind of like, if this helps, how are these two numbers related? I can't go lower than the biggest number. So I can't say something like, oh, put them into halves. I have to go with something that the 6 will be able to go into. Right? So that's why I said, take a look at that big number and think about what that one will go into, And will 4 do the same thing? So I said, okay, well, 6, the lowest number I can think of that 6 will go into evenly is the 12. And it just so happens that, yeah, 4 will go into the 12 as well, right? So that's why I chose the 12. It's the lowest number that the 6 will go into, but it is still a multiple of the 4s. 4, 8, 12, right? So I needed to put them into 12, so I had to turn the 6 into a 12. That's where I said I multiplied it by 2. And remember, whatever I do to that bottom number, I have to do the same thing to the top. So I multiplied 6 by 2. I have to multiply that 5 by 2 as well. I needed to make the 4 into a 12. So I had to multiply 4 by 3 to make it 12. 4, 8, 12. Whatever I had to do to the bottom, I have to do to the top. Right? So that's how I ended up with the 12s. Does that make it a little... Did that explain a little bit more, Philman?
Yeah, I got it. Thank you.
Okay, you're welcome. Right? And then again, we ended up with a numerator that was bigger than the denominator. And again, that's our improper fractions. Right? And I think it was in that one there. Or did I have it there too? Right? So remember, improper fractions, the numerator is equal or greater than the value of 1. Right? So we had the 13 over 12. And remember, and again, I'm just doing this more for your benefit there, Aaron, just to keep you on speed. Essentially, it's like saying 13 divided by 12. Well, 12 will go into 13 once. 1 times 12 is 12. Right? And we're left with 1. And if you remember how we did it before, that is your wholes. That is still going to remain your denominator. And this leftover is your numerator. So there's my whole, my numerator, and then my denominator. Right? So 13 over 12 is equal to saying 1 1/2. And again, or sorry, 1 1/12. Oh dear Barbara. 1 1/12. How'd that go? So? All right, now that we touched into a mixed fraction, so we turned our improper into a mixed, let's do some adding of some mixed fractions. All right, so I'm going to throw this one out. Let's do, I'm going to go up here and do this one. Let's go with, I'm going to call this one question number 1 again. And we'll go with 1 whole, so 1 3/4 plus 2 5/8. And I'm going to show you what I'm going to do here. So when we have our whole numbers, we can essentially take these whole numbers and kind of put them in a little room by themselves. Isolate them from the fraction, okay? Because they essentially can be treated as their own set, right? And if you want, we can actually even do this. We'll put it over here. So 1 plus 2, right? It's like we're hiding the fractions for a second and just dealing with the whole numbers. 1 plus 2 gives us 3 wholes. Then I'm just left with the 3/4 plus 5/8. But I have an apple and an orange. So I have to turn them into something that I can use. What would be my common denominator here? Again, look at the biggest number and see, will the other numbers or other denominators go into that largest denominator? And in this case, yes, it will. So I looked at my biggest number. I have my 8, right? Well, the 4 will go into the 8 evenly. So the only numbers that we're going to change here is the 3/4. So in order to make the 4 into an 8, I have to multiply it by 2. Whatever I do to the bottom, I must do to the top. So now this equation is going to read like this. 6/8 plus 5/8. Right? So the answer is going to be something over 8. Right? So 6 plus the 5, we get 11. Again, an improper fraction, right? 11/8. So let's turn that improper into a mixed. Okay, again, it's like 11 divided by 8. 8 will go into 11 one time. And again, here, I'll just write this out real quick if you need it. Goes in one time, right? 8, 9, 10, 11. So you're left with the 3. So there's our whole, our numerator, and our denominator. Okay, but that's not where we end. We still had this 3 sitting in its little room by itself, waiting for us to finish with the fractions. Well, I'm just going to take that baby and add it over here. But I'm only adding the whole numbers together, right? So then I'm left with 4 and 3/8 as my answer. Does that make sense? Right? So this is where I'm saying for adding and subtracting, I need to have my bottom numbers the same. I'm going to give you another one with mixed fractions. And then I'll turn the page and we'll do the multiplying. So let's do this one. Yeah, all right. Well, 1 and 2/3 plus 3 and 3/4. All right. Give that one a try. I'm going to put the